All right, today's lesson we are going to talk about a lot of vocabulary, a lot of terms, and we're going to bring together all the work we've been doing with factoring and what it is used for. Now, the very last step in today's lesson is going to involve solving little tiny equations like this. And it's a real shame to me when I have students who do all this beautiful work and then get down to the last step and mess up. So I want to make sure that you can solve these little baby 1 and 2 step equations. Kids don't like equations that look like this. Why? Because it's set equal to 0, and for some reason that freaks kids out. But it's a very simple problem. Look at number 1, x minus 7 equals 0. What number minus 7 equals 0? 7. Okay, so all you got to do is follow your rules. Get rid of the minus 7 by doing plus 7, and 0 plus 7 is just 7. So it's a very simple equation. Doesn't 7 minus 7 equal 0? That's the answer. Sometimes you get a little one-step equation. Number 2 is also a one-step equation. What number plus 5 is 0? Negative 5. So you're going to move the 5 over, subtract 5, and you get negative 5. Now, 3 is a little bit more complicated. 3 is actually 2 steps. But you solve it just like you do any other equation by doing inverse operations. You got to make that negative 3 go away. How do you get rid of a negative 3? Add 3. So my new equation is now going to be 2x equals positive 3. And then divide by what? Divide by 2. So x would equal 3 over 2. Or 1.5 or 1.5 if you're a decimal person. Okay, so this is going to be the very last step on today's problems. Except you're going to have 2 equations at a time. You're going to have to set them equal to 0 and solve this little baby equation. So if 5x plus 1 equals 0, first step, move the 1 over. What would 5x equal? Negative 1. So what would x equal? Negative 1/5 or negative 0.2. And I don't mind if you leave them as fractions. Alright, how about this solution? X equals 5/7. We're going to move the negative 5 over and it becomes positive 5. Then we're going to divide by 7. If you want to do it one step at a time, that's fine. 7x equals positive 5 because I added 5 to both sides. Divide both sides by 7 and we get x equals 5/7. See how easy these are? Yes. Yes, because you're going to end up dividing by that number. She said to put the number with the x underneath the fraction bar. And yes, because look at this. I know at some point I got to divide by 3. So 3 is going to be under the fraction bar. Before I divide by 3, though, I got to move the 8 over. So this would be 3x equals not 8. Negative 8. You got to subtract 8 to get that number to go back to the other side. And then divide by 3. So x equals negative 8/3. Okay, so once you do several of these, they should only take a second to do that last step. What about this problem? 2x equals 0. For some reason, this bothers kids as well. X equals 0. Divide by 2. What's 0 divided by anything? 0. What about 7x minus 8 equals 0? See if you can do that real quickly. 8 over 7. Move the negative 8 over, it becomes a positive 8. And then divide by 7. And you get 8/7. Are you with me there? Okay, there's several parts to this lesson. What we are doing today is finding the zeros. So why do you think we did that warm-up we did? What were all those equations equal to? 0. So finding zeros involves setting something equal to 0. We're finding the zeros of quadratic functions. So let's get some vocabulary out of the way for a second. First of all, zeros have lots of different names. They're called zeros, they're called roots, and they're also called x-intercepts. All of those are used interchangeably. So if you're asked to find the roots, that means find the zeros. If you're asked to find the x-intercept, that means find the zeros. And the way you do that is you set it equal to 0. So all of these mean the same thing. And what these are, it is where a function, and we'll talk about function in a minute, where a function crosses the x-axis. That's why it's called an x-intercept sometimes. This is why it's called a zero sometimes. Anytime you're on the x-axis, let's think about the x-axis. Let's name some of the points that are on the x-axis. Just back to graphing points. What's this point right here? Not just one, a point has two numbers. 1, 0. What's this point? 2, 0. What's this point? 3, 0. What's this point over here to the left? -1, 0. What do all those points have in common? They all have zeros where? At the y. At the y. So an x-intercept literally happens when the y value is 0. That's why they're sometimes called zeros. That's why they're called x-intercepts, is because it's when you're actually on the x-axis. And anytime you're on the x-axis, guess what your y value is? 0. So where a function crosses the x-axis, that happens when the y value is 0. And sometimes they're also called roots. Are you with me there? Okay, can I erase this? Now, we're going to look at a function real quick, a quadratic function. Y equals x squared minus 9x plus 14. That's a quadratic function. How I know it's quadratic is if the highest exponent is a 2. Now, what do quadratic functions look like? They're called parabolas. They could open up, they could open down, they could be real skinny, they could be real fat. Those are all parabolas, and they all have some kind of equation where it's got an x squared in there somewhere. Okay, so quadratic functions are sometimes called parabolas. So that's another vocabulary word you got to be familiar with. Now, parabolas have millions of solutions. Any function has millions of solutions. To find the solution to a function, all you got to do is you pick an x number, any x number you want, you plug it in and do the math to it, and out comes a y value. So any point that falls on the parabola is a solution to the parabola. Now, we're obviously not going to find every single solution. We're looking at some very specific solutions today. Just let's look at a parabola and talk about what do you think might be some important points. So let's say here is my parabola. What do you think might be some important parts of a parabola? Where it crosses the x-axis, where it crosses the y-axis, those are absolutely important points. Anything else? The end, okay, or the lowest, or this is sometimes called the vertex, the turning point, the minimum. In some cases, it's a maximum point because it might be at the top, either the bottom or the top, depending on what kind of parabola you're looking at. Okay, so there's lots of parts to a parabola. We're going to talk about all of them. Guess what we're focusing on today? The x-axis, the x-intercepts, the roots, the zeros. That's the only part we're going to look at today. Now, all that stuff we've been doing for weeks and weeks and weeks is going to help us find those zeros, find those roots, find those x-intercepts. What have we been doing for weeks and weeks and weeks? We've been factoring. So factoring helps us lead to the zeros of a quadratic function. Okay, now, again, zeros aren't the only points on a parabola, but they're two of the, well, sometimes there's two of them. Today's problems should be rigged to where there's two of them. Here's a clue that I'm going to have two roots. The exponent is a 2. However, not every parabola is going to have two roots, but the ones we're looking at today will. Another thing I want to talk to you about is function notation, because you might see this on a CBA, and we haven't really dealt with it yet. These two things mean exactly the same thing. I don't know if you've ever seen this last year with Miss Wen. F of x equals x squared minus 9x plus 14. F of x is a fancy way to say what? Y. That's all it means. But some kids get confused when they see this because they think they're supposed to multiply two numbers together here. That is not what's happening. So if you see f of x and that confuses you because you think it's two things, two numbers getting multiplied, what can you put in its place? Y. All you got to do is take it out and put a y in. I don't know. All this means is this is a function that depends on x. All functions depend on what you put in for x. Now, what we're going to do today is we want to find the zeros. So guess what we're going to put in for y? 0. We want to know when this function is going to equal 0. In other words, we're finding its roots, its x-intercepts, its zeros. Now here's another property that you got to be familiar with. So let's think about this for a minute. Pretend like I'm thinking of two numbers. And I want you to see if you can guess at least one of my numbers, and I'm going to give you a hint. If I multiplied my two numbers together, they equal 0. Can you guess one of my numbers? One of them has to be what? 0. If you multiply two things together and they equal 0, what does that mean about the two numbers I'm talking about? One of them has to be 0. This is called the zero product property, and this is also used today in our lesson. Zero product property. That means if you have two numbers or two factors or two of anything that you know multiply together to equal something 0, or to equal 0, that means that either A equals 0 or B equals 0, or what else could be possible? Or they could both be 0. And in today's problems, they both are going to be equal to 0. All right, now, what have we done with x squared minus 9x plus 14 and things like it for weeks and weeks and weeks? Factored it. So factor that. The first step to any factoring is ask yourself if there's a GCF. Is there? No, so you just start factoring. You just keep on bringing it down. Raise your hand when you know the factors. Okay, good. So what does this factor into? X minus 7 and x minus 2. So you got to be careful that you got the right signs and the right factors, or else this is not going to work. Here's another thing you got to be very, very, very careful with. These are factors. Factors look like stuff in parentheses most of the time. Today we're not stopping at the factoring, because today we actually know what we want it to equal. What do we want it to equal? 0. All the problems you did and all those homework assignments we did, they never equaled anything. Today, guess what they're going to equal? 0. And if they equal something, we don't want to stop at the factors. We want to stop at the solutions. So we're going to actually keep solving this. So here's where that zero product property comes in. If A times B equals 0, what do you know about these two factors? One of them has to equal 0, or both of them have to equal 0. Here's where that warm-up we did comes in. You're going to take each separate factor and solve two little baby equations. We're going to assume that the x minus 7 factor equaled 0. And we're also going to assume that the x minus 2 factor equaled 0. Those are my two factors. I'm actually going to set them equal to 0, and I'm going to keep on solving. So if x minus 7 equals 0, what's the solution? X equals 7. 7 minus 7 is 0. If x minus 2 equals 0, what's the solution? X equals 2. Those are the two roots of this problem. That's where this parabola does what? Hits the x-axis. These are the roots, the zeros, the x-intercepts.
It hits at 7, 0 and 2.
Very good. Let's talk about the ways your answers will be shown. It hits at 7, 0 and at 2, 0. Sometimes the answers are shown as points, and the y value will always be a 0 because we're finding the zeros. Sometimes you could just write it like this: x equals 7, x equals 2. Now this is called set notation, where I just write the two answers in the set notation. 7, 2 are my two answers, or 2, 7. Here's what I don't want you to do. Don't write it in parentheses, because what does it look like then? Like the point 7, 2. And it's really not. The 7 and the 2 don't make a point together. They make two different x values. Now, you will be getting calculators soon, I promise. Let's just look at a picture of this. We'll do those, I promise. All right, I'm going to put this into my calculator. Y equals x squared minus 9x plus 14. And then I'm going to look at a picture of it. Now, I said the answers were 7 and 2. Does that look correct? Yeah, look where it's crossing right there. What one is that? 2. 2, 0. What one is that? 7, 0. There's my two roots, my two x-intercepts, my two zeros. All right? What was your question? You can do this in the calculator, but they will have problems that require you to factor on the end of course exam. Some kids were really mad at me that we did all that factoring. If you can use the calculator to find them, and you can, but you will have questions where you have to factor. All right. Number 2. Let's try this one. Y equals 3x squared plus 8x minus 3. Okay, that's a function. How do I know it's a function? Because it's y equals blah, blah, blah. How do I know it's a parabola or a quadratic function? Because the exponent is a 2. How many solutions are there to that function? Billions upon billions upon billions. What points are we interested in today? The zeros. So what are we going to put in for y? We're going to put in 0. Usually, how many zeros will there be?
No,
2. Usually a parabola will have 2 zeros. Yes. Yeah, if you wanted to find the 2 of the function, you would set y equal to 2. Yeah. But we're trying to find the zeros of the function. So we're going to replace y with 0. Real quick, let me just show you all the possibilities about a parabola. You might have the ones you're going to do today should usually cross twice. But you might have a parabola that only has one root. And that's when the turning point is actually on the x-axis, where it only crosses one time. And sometimes you're going to get a parabola that never crosses the x-axis. It would have no roots. Now, the ones you're going to do today are rigged to where you can factor them, and you will be able to find the roots, and most of the time it's going to have 2. Okay, so now this one, there's another thing you can tell. I can tell if this is going to be a smile parabola or a frown parabola, and the way I can tell that is just by looking at the first number in front of x squared. It's a positive number, so this is going to be a smile. It's going to open up. And we'll do more of that stuff later on. But right now, all we want to do is find the zeros. So we're going to set this whole function equal to 0 to find the zeros, the roots, the x-intercepts. And there's lots of ways to do it, but the only way we know how to do right now is to factor it. And if you mess up on the factoring, it's going to mess up your roots too, so be careful. Is there a GCF? No, so I just start guessing and checking. You can't simplify this one because there's no GCF. Oh, when you're finding the actual answer? Yeah, your answer should be in lowest terms or whatever. But what does this factor into? 3x minus 1 and x plus 3. And if you get any of that mixed up, it's not going to give you the right solutions. This would give you 3x squared plus 9x minus 1x. That's how we get the 8 in the middle. And then you'd get a negative 3 on the end. So your factors have to be correct or it's not going to give you the right answer. Now, here are my two factors. Make sure you understand the difference between factors and solutions, because every year when we get to this lesson, I have kids who stop right there. Are those the roots? No, those are the factors. I'm almost there. I'm almost about to find the roots, the zeros, the x-intercepts. I have to actually set each factor equal to 0 and find both zeros, find both answers. So you got to move the 1 over. This one's going to be a fraction right here. You would get 3x equals 1. And what would x equal? 1/3. What would x equal here? Negative 3. There's my two roots, which can be shown as x equals 1/3, x equals negative 3, or as two separate points, 1/3, 0, negative 3, 0. That's another way you might see them. Or in set notation, negative 3, comma, 1/3. You'll see them all different ways. Those are the two x-intercepts, the two roots, the two zeros of that particular function. And let's just look at it and just to verify. Y equals 3x squared plus 8x minus 3. And again, we said the answers were negative 3 and 1/3. So let's see if that looks correct. Does it look like negative 3 is where it's crossing? And this one is hard to tell from a picture, but 1/3 should be somewhere between 1 and 0. Does that look correct? Yes, and it is, because I know I factored it right. All right, number 3. F of x equals 3x squared plus 14x minus 5. And our job is to find the zeros or find the roots or find the x-intercepts. What does f of x mean? Just means y. So what are we going to put in place of y? 0. You can put it on either end. Some kids like it over here on the right. You could put y equals y on either end or f of x equals on either end. So I'm going to switch it around and put it on the right. So I put a 0 in for f of x and then I switched it to the other side. And now how do I find the zeros? Factor it. And the first step of factoring is to ask yourself if there's a GCF. And if there's not, which there isn't, you just start guessing and checking until you find the right factors. A hint that you're going to have a fraction answer, guys, if you look in front of x squared and there's a number there that's not a nice invisible 1, that means you'll probably have at least one fraction answer. Did you get a fraction answer here? Because you're going to have to divide by this 3 eventually. What are the factors? Again, these are factors. You got to know the difference between a factor and a solution. What are the factors? 3x minus 1. X plus 5. Let's make sure that works. That gives me negative x, positive 15. That's correct. That's the correct factors. Now, to lead to my solutions, in other words, my zeros, my roots, my x-intercepts, I have to set each little factor by itself equal to 0 and solve these little baby equations. If 3x minus 1 equals 0, what does x equal? 1/3. If x plus 5 equals 0, what does x equal? Negative 5. There's my two solutions. I have found two important points on this parabola. And if I wrote them as points, what would it be? 1/3 comma 0, negative 5 comma 0, and if I wrote it in set notation, It'd be 1/3 comma -5 or -5 comma 1/3 with that fancy set notation. Okay, let's double check real quick. If you have access to a graphing calculator, you know that you can put an app on your phone, by the way. It's still cheaper than an actual graphing calculator. It's not a bad idea to invest in one for your future Adobe anyway. Graphing calculators are about $100. The app is cheaper than that. Okay, 3x squared plus 14x minus 5. Now let's look at a picture of it. The intercepts were supposed to be, the x-intercepts were supposed to be at -5. That looks correct to me. 1, 2, 3, 4, 5. And 1/3. That looks like I did it right. Okay, now I want to show you all kinds of weird situations that you might encounter, so stay with me here. X squared minus 16 equals y. Now that is a parabola. I know it's a parabola. I know it's quadratic because it's got an exponent of 2. How many times do you think it's going to cross the x-axis? Probably twice. Usually the highest exponent tells you how many times it's going to cross the x-axis. Now, we want to find, this has millions of solutions, billions upon millions upon trillions. We only are interested in very specific solutions called the zeros or the roots or the x-intercepts. So what we're going to do is set that equal to 0. Difference of two squares. This is the difference of two squares, which is actually very easy to factor. What does this factor into? X plus 4, x minus 4. And again, please make sure you know the difference between factors and solutions. The parenthesis part is the factors. Those are not solutions. Solutions are just what does x equal? What are my two solutions? Yes, so this should cross the x-axis at -4 and +4. Oh, does it matter which way you write the answer? No. If you want to write it as two separate points, that's fine. If you want to write it as x equals, that's fine. If you want to write it in a set notation, that's fine too. Whatever way you like the most. I want you to understand, though, it could be shown all three different ways on a CBA. What they shouldn't do is write it like this. That would be a typo. Why shouldn't they write it like that? That looks like a point, -4, +4, and that point is not on the graph. All right, let's just check it real quick. Y equals x squared minus 16. Well, sometimes when kids see difference of two squares, they forget how to factor it. See how it's crossing at -4 and +4. -4 and +4. Okay, here's another weird case. Number 5. Don't panic when you see a problem like this. Now, the ones on your homework, by the way, they're already going to be set equal to 0 for you. They're not going to be y equals. They're just going to be blah, blah, blah equals 0, which means you're finding the zeros. This one has a GCF. What's the GF? I mean GCF? 3x. And what are you left with? X minus 5. Sometimes factoring out the greatest common factor is all you can do. How do I know I'm done factoring? There's no more exponents. This time my factor is just 3x and x minus 5. I did have two factors, so I have to set each factor equal to 0, and then I keep solving. This is the one that freaks kids out for some reason. Divide by 3. What's 0 divided by anything? 0. What's the answer over here? 5. This one's crossing at the origin. What point is this? 0, comma 0, and this point would be 5, comma 0. Sometimes one of your zeros is actually 0. Because the GCF was 3x. That's how I got 3x. All right, let's let's look at a picture of this. 3x squared minus 15x. It's supposed to cross at 5, 0, and 0, 0. There's 5, 0, and there's 0, 0. Sometimes it's so close to the x-axis it's hard to see, but it's crossing at 0, 0, and at 5, 0. And if you wanted to be sure, you could look at the table of values. Look right there. When x equals 5, look what y equals. 0. And when x equals 0, look what y equals. 0. Those are definitely the two zeros, the two roots. Okay, so that's another weird case when your factoring is basically just getting a GCF out and you're done factoring. But again, please don't stop at the factors. Those are factors. These are actually solutions. Okay, two more weird cases and then I'll let you start your homework. Number 6. Now look at this problem, please. This is not a parabola. How do I know this is not a parabola? It's got an exponent of 3. So this is not going to make that same shape. But I think you're going to have a few like this. So this is technically not a parabola. And guess how many roots it's going to have? 3. It's going to cross the x-axis 3 times. I'll show you a picture of it in just a second. But let's talk about how to find the zeros. We're going to set it equal to 0. Boys. First step on any factoring is GCF, which this has one. What is it? X. Take out an x and look what you're left with. You should be familiar with what you're left with. What is this called? The difference of two squares. How does x squared minus 25 keep factoring? X plus 5, x minus 5. So, do you see how I had 3 factors? Now I'm going to have 3 solutions. So I have to set each little factor equal to 0 and keep on solving. One of them's already solved. What's one of my solutions? 0. It's crossing at the origin right there. What's this solution? Negative 5. And what's this solution? Positive 5. So as points, it would be 0, 0, negative 5, 0, and 5, 0. As set notation, it would be negative 5, 0, and 5. Those are my 3 roots to this one. Well, you got to count every single solution here. If it's got 3 factors, it should have 3 solutions. You set every single factor equal to 0. Now, let's look at a picture of this guy. X to the third minus 25x. So it's not a parabola. It makes like a snake shape, kind of. It goes like this. It's crossing at negative 5, 0, at 0, 0, and at 5, 0. It's crossing in 3 places. We can't see the top and bottom because our screen isn't big enough, but it's doing something like this here. Oops. Something like this. Crossing here, here, and here. Okay, one more weirdo, and then you can try these on your own. Number 7. Y equals 2x to the third minus 2x squared minus 40x. How do I know this is not a parabola? Because the exponent's a 3. It's going to be that little snaky shape. It's going to cross the x-axis how many times? 3 times. So we're going to set it equal to 0. We're going to take the y out and make it the y value is 0. Because that's when an x-intercept happens, when y is 0. And we're going to factor it. GCF is the first step. And if you don't get the GCF out, you can't factor it. What is the GCF? Yeah, it's 2x. Which makes the factoring a lot easier once you get that 2 out of there. What are the factors of 20 that could make a negative 1 in the middle? Y'all need to be doing these in your notes, please. So this is going to continue to factor to x, what? X plus 4 and x minus 5. So here are my three factors. 2x is a factor, x plus 4 is a factor, x minus 5 is a factor. So you have to set each factor equal to 0 to find the solutions, and then you keep solving. Well, if 2x equals 0, what does x equal? 0. This one also crosses at the origin. What does x equal here? Negative 4. And what does x equal here? Positive 5. So I have three solutions. 3 points would be 0, 0, negative 4, 0, 5, 0. And in set notation, you could just list them. Negative 4, 0, 5. Let's just double check ourselves. Let's look at a picture of this guy real quick. Y equals 2x to the third power minus 2x squared, and then minus 40x. And sure enough, it's hard to see, but it's definitely crossing at negative 4. Here's where it's crossing at 0. It's just hard to see because it's so close to the y-axis. And there's that last one at 5 right here. 1, 2, 3. Okay, your homework is page 190, 10 through 24. You're doing all of those. Please make sure you don't stop at the factors. We're looking for solutions. It's actually equal to 0. When it's equal to something, you want to actually solve it. Look at number 10 with me, please. I want to point out something. I don't like that they did this, but they didn't really set this up like a parabola. They used all kinds of different letters. They used Y's and A's and B's and M's and N's and X's. Really, it should always be X's. The Y value is what it's supposed to be equal to, but that's okay. If you want to change them all to X's, you can. Plus, they already set them equal to 0. So they set it up for you to tell you, hey, you're finding the zeros. All right, any questions? Yes. Will you find the minimum or maximum?